Hello students! Previously we studied functional groups. We know that functional groups are a group of atoms that impart specific properties to the compound to which they are attached. This is because functional groups bond with the compound so strongly that they influence and determine the major properties. If this is a hydrocarbon compound, and this group of atom, what we call as functional group, gets attached to it, will take on the new properties of this functional group. So let's see functional groups one by one. The first in the list is the functional group halogen. The halogen group includes elements such as fluorine, chlorine, bromine and iodine. As we know, the name halogen is derived from two Greek words, where halo means salt and gen stands for generates or forms. Thus, these halo elements combine with metal elements to form variety of salts with similar properties. Now coming back to our halogen functional group. If the hydrogen atom in the hydrocarbon chain is replaced by the halogen atom, it forms the respective halo compound. Having said that, in this case, the heteroatom replacing the hydrogen atom can be any of fluorine, chlorine, bromine or iodine, thus forming new carbon compounds. Now, how will you name these newly formed compounds? It's easy. If the carbon compound has fluorine attached to the chain, the name of the compound will be prefixed with fluoro. And if a chain has chlorine heteroatom attached to it, the prefix chloro is added to the name. Let's see it with an example of propane. To which series does this propane belong? It's a member of alkane compounds. What is the molecular formula of propane then? Yes, as we know, prefix prop means there are 3 carbon atoms in the chain and ane means it is a saturated hydrocarbon, belongs to alkene series. Thus, its chemical formula is CH3, CH2, CH3 and its structure can be represented like this. Now, if one of the hydrogens in the propane is replaced by chlorine, we get a new carbon compound like this. What will be its name then? Yes, as you know, if there is chlorine, add the prefix chloro. So here it will be called chloropropane with a molecular formula of CH3, CH2, CH2, Cl. Since one hydrogen is replaced by chlorine and a structural formula like this. Now this is true for any other halogen atom. These elements can replace H atoms in alkenes and alkynes as well. For example, if we take butane of alkyne group, its molecular formula is C4H6 and its structure can be expressed as CH3CH2CCH. Now, if one of the hydrogens in butane is replaced by bromine, we get a new carbon compound with molecular formula C4H5Br or CH3CH2CCBr. Observe that here H is replaced by Br, which is a haloalkyne. So what will be its name? Correct. Since it is a bromine which has replaced hydrogen, it will be bromobutane, where bromo is a prefix for halo group bromine and butane is the parent compound chain. So to generalize, if the hydrogen is displaced by halogen atom, the new compounds formed are called haloalkanes, haloalkenes and haloalkynes respectively. Next on the list is functional group alcohol. The alcohol group consists of one oxygen and one hydrogen atom. Together, they are 1-hydroxyl group OH. Now this is nothing but an alcohol functional group denoted by dash OH. If one hydrogen atom in the chain is replaced by this hydroxyl group, then the resulting carbon compound is said to have an alcoholic functional group. What about its name? If the alcohol functional group is present, the name of the compound will have suffix -ol. For example, if this is an hydrocarbon compound, say propane, if one of its hydrogen is displaced or replaced by hydroxyl molecule OH, we get an hydrocarbon compound with an alcohol functional group. If OH group attaches to propane, it becomes propanol. Thus, if OH group attaches to ethane, it becomes ethanol. If it attaches to butane, it becomes butanol, and so on. Similarly, if it replaces one hydrogen in butane, the new compound will be named butanol or but-ine-ol. Here, but is a prefix showing that compound has chain of 4 carbons. Ine shows it has 1 carbon triple bond, and the last suffix ol shows functional group alcohol or hydroxyl group attached to it. In general, alcohol compounds are used as solvents in laboratories. They are also used in making hand sanitizers or as an antiseptic agent. They also form the basis of many alcoholic beverages. Many of them use alcohol compound ethanol as a base. Now let us go ahead with the third functional group, aldehyde. The aldehyde group consists of one carbon atom attached to an oxygen atom with a double bond and a hydrogen atom with a single bond. How does this group bond with the carbon chain? As we know, carbon can share 4 electrons as its valency is 4. Out of 4, it shares 2 electrons with oxygen as the valency of oxygen is 2, and 1 electron with hydrogen as its valency is 1. This makes a total of 3 for carbon. Thus, 1 valence electron is still with carbon to make a bond. This electron is shared with the carbon of any other alkyl group to form the bond. Yes, so the aldehyde group gets attached to other carbon compounds by its carbon atom. This is represented by a dash in front of the carbon atom, like this, dash CHO. If the hydrogen atom in the hydrocarbon chain is displaced by aldehyde group, it forms a new class of compounds with new properties. And what are you going to call these compounds? It's easy. What did we do while naming the compounds in alcohol group? Pause the video, take a second and recall that. Yes, we added the suffix ol behind the name, isn't it? Yes. Something similar happens here. When aldehyde is attached to carbon chain, the suffix al or al is added after the compound name. For example, so if one hydrogen is replaced by this aldehyde group in ethane, we get this compound and its name will be propanol. This is because we just add the suffix al to the name propane. Its molecular formula will be C3H5CHO, also written as CH3CH2CHO. Similarly, if we replace one hydrogen from butane, we get pentanol or pent-ine-al. Pent which means there are 5 carbons in the parent chain. Ine is for alkyne, that is, it has at least 1 carbon-carbon triple bond, and al for aldehyde functional group. Aldehyde compounds are versatile reagents used for a variety of organic synthesis. Many aldehyde compounds are obtained naturally and are aromatic agents. They are main aromatic agents in fresh almonds and vanilla essence and give them their typical taste and smell. We use these aromatic agents in ice creams, desserts, etc. So in the next video, we will continue to learn about some more functional groups.